Those Space People, a podcast series of casual cosmic conversations with people working on exciting space projects. So today we have Abhijeet Borkar with us. He is a research scientist at the Astronomical Institute of the Czech Academy of Sciences, and he has a PhD in astronomy and astrophysics from the University of Cologne in Germany. And Abhijeet is currently based in Prague. Welcome to the podcast, Abhijeet.
Thank you so much for having me, Rachana.
First of all, what is the official name of this Astronomical Institute of Czech Academy of Sciences in Czech, and how do you say it?
Yeah, so in Czech, it's called Astronomický ústav Akademie věd. Akademie věd is the Czech version of Academy of Sciences, and it's a umbrella organization that includes several different institutes for each different subject. So you have Institute of Physics, Geophysics, Astrophysics, Biochemistry, and so on and so forth. So ours is one of the 45 or something institutes. It's kind of equivalent of the Max Planck Institute in Germany.
So you started with your bachelor in physics, right, from Ferguson College in Pune, India,
Yes.
and then you continued with a master degree at the same place, and then you moved to Cologne for your PhD. But this was more than 10 years ago. So for someone interested in pursuing a career in astronomy, astrophysics, or taking a similar path as you have currently right now, is this the optimal path, or are there any other options like, getting some work experience along the way or something else?
Yeah, I think within India itself, there are quite a few different options. Especially nowadays, there are a lot more options available in terms of there are IITs which offer different physics courses. So, especially experimental physics course is quite similar to what we do in physics in general sciences. And there is also ISER, so Indian Institute of Science, Education and Research. So there are quite a few of those institutes now in India also. So from there you can do a combined bachelor's and master's program, so a 5-year program that gives you a master's degree in the end. And that will be also a fantastic way of starting the path towards doing a career in astronomy. So I think that would be a very good start. So these are kind of the premier institutes. I think, if I'm not mistaken, even IISc has a bachelor's program. So some of these institutes will have a bachelor's program, and many of them further will have a master's program also. So combining these two together will be kind of like the best way you can do it within India.
Then, after completing these programs, what could be the opportunities?
Yeah, so within India, there are quite a few research institutes which allow you to do PhD in astrophysics. So there are a few dedicated astronomy institutes, for example, the National Center for Radio Astrophysics in Pune, or IUCA in Pune also. There is also Raman Research Institute, Indian Institute of Astrophysics in Bangalore. So these are kind of dedicated astronomy institutes, but there are also general science institutes like TIFR and IISc and so on, which have astrophysics as a program for PhD. And of course, there are quite a few of the dedicated teaching institutes like IITs and ISERs, which may also have some possibility of doing astrophysics PhDs. So these are kind of various different options you can look for if you want to stay within India. And then, of course, outside of India, there are many more opportunities also.
Speaking of outside India, right, what made you choose the Czech Academy of Sciences for your postdoc?
Actually, it was a quite easy decision. So for during my PhD, I was collaborating with some of the people here in Prague on a couple of projects. We had written one or two papers together and had quite a few discussions. I had visited in 2014 as a visitor for a week or so. So I already had a connections with people here. And as I was finishing my PhD, I was informed by the director of the institute here that there is a position open available here and I should apply. And that was the only position I applied for a postdoc before I was completing my PhD. And because I got the position, I did not plan applying to other places. So that way I got into Prague, and then I have been working here since then.
Ah, okay. That sounds pretty smooth sailing.
Yeah, I think at least in my experience, what I've seen is that getting a random job in academia is quite difficult in terms of like applying for 15, 20 places and just finding a position that is matching for you. Often a lot of the positions you get are through networking and knowing people and people you have worked with, and then it's much easier to know what jobs are available, what kind of uh, projects they're doing and what their requirements are. So it's much easier to get the positions that way rather than. I mean, it's still possible to apply for many different places, and usually people will apply for 10 to 15 places at least, maybe sometimes even more, and have interviews and so on. But often it's the case that if you have good connections, then the chances of you getting a position are higher.
Oh, okay. You obviously collaborate with your fellow researchers across the world, right? So is this the same across geographies? For example, in the US?
Yeah, in general, people will be collaborating with a large number of people as they, especially once you go further up in your career, you start making connections with more and more people. You start working on different projects, and you start getting specializations in one topic, and then you want to also combine that specialty with something else. So you look for specialists in those areas, and then you combine your work together to collaborate. So this is quite common in all sciences, but in astrophysics especially, because one of the limitation is that astrophysics is often divided into different frequency bands in electromagnetic spectrum. So there are X-ray astronomers and optical astronomers and radio astronomers and so on. So in that case, if you have an expertise in optical astronomy, it's not guaranteed that you will know everything how it goes in radio astronomy. So you collaborate with radio astronomers. Sometimes you also collaborate with theorists or people who do computational simulations. So all of that together is how you sort of build a team, and you sometimes also just require a few experts on specific topic to give you some advice and so on. So that way you also get in touch with some of the experts in the field to give you advice or interpret some of the results that you may not be sure of. So this way you build your collaborations, and this is kind of similar in most of all over the world.
I really want to know about your current work, but probably a better way to frame that is how similar or different are the PhD thesis research that you have done and the subsequent postdoc work and your current research.
Right. So actually, this can be answered in multiple different ways. So in terms of science, my work is somewhat different in the sense that my PhD was very much focused on one specific object. So the object was the supermassive black hole at the center of our galaxy. So that is a very well-known object. It's a extremely well-studied object, and being the nearest black hole as well as it's our black hole in the Milky Way. So it has all the telescopes always pointing at it many times. So that was a very specialized object. So it's also considered to be a non-active black hole or very low activity black hole. So it does not do too much of the accreting of the material and eating a lot of gas together, and it does not give off too much light also. So it's not a prototypical active black hole. So that way, it was a very specialized subject. And then for my postdoc, I am working on uh, research which involves a lot of active galactic nuclei, which are much brighter, much more active. They're accreting a lot of material together, and we are trying to understand different concepts about the physics around the accretion of the black hole. So some of these things are quite similar to what I did in PhD, but there are also quite a few differences in terms of instead of working on one single object and its evolution within days or years, I'm looking at a sample of sources and looking more statistical data analysis and so on. But overall, the science is kind of similar. On the other hand, technically, it's more or less the same. I was a radio astronomer during my PhD. I worked on radio data analysis in millimeter and submillimeter wavelength, and I'm also continuing to work primarily in that field. But also, I'm now also working with a lot of data from X-ray telescopes and optical telescopes and so on. So it's kind of evolution of what I was doing during my PhD and continuing to work scientifically on that. But apart from that, I also work not just on my own pure research, but part of my job is as a contact scientist for one of the radio submillimeter telescopes, which is called Atacama Large Millimeter Submillimeter Array, ALMA, which is operated in Chile, located in Chile and operated by the joint ALMA Observatory. And it's kind of owned by North America, Europe, and East Asia. So there is a regional center in each of these continents, and we are part of the European Regional Center. So what we do is provide user support for people who want to use the telescopes to provide them help with writing proposals for observing with the telescope, analyzing their data, helping them with data analysis and results, and also helping them with any complications that can arise. Along with that, we also develop new observing techniques, data analysis scripts, and programs for the telescope, developing data products from the telescope itself. So there are quite a few of the things that we do as part of the job of contact scientist for the telescope. So it's kind of halfway between a customer support job for astronomers and a technological development job.
That actually sounds fun.
Yeah, in general, it's quite fun in the sense that you get to learn so many different topics that you're not expert in because you're talking with so many different people and their topics are completely different from what I study on. So, for example, I study black holes, but I talk to people who study galaxy star formation or how planets are forming, or they're looking at something in the solar system itself. And our node, so there is a node of the European Regional Center in Czech Republic, and we have the expertise of observing the sun with the radio telescope. So there are people who are observing the solar corona and sunspots and so on. So we get to talk to them to understand what uh, kind of observations they want to do and how they can use the telescope for those.
Okay, wow, this sounds super fun. It's like you're living inside one of my favorite space sci-fi books.
Yeah, it's always fun to. I mean, the day-to-day job is mostly looking at computer programs and trying to debug code. It's not as glamorous as people think, but you have to sort of every few weeks you have to sit back and think about larger picture so that you don't miss out on the big picture view of the topics that you're working on, because on the day-to-day basis you're just looking at, oh, this snippet of the code is not working, or I'm getting so many errors, or I have to write so many papers and so many reports for this grant report and so on and so forth. So there is quite a lot of administration involved also, so you have to really take a step back and then remember that you're doing something really cool.
Yeah, absolutely. And not to mention all the pages of documentation as well.
Yeah, the procedure for being an astronomer is quite complicated. I mean, this is true in academia, but for example, one of the things that astronomers do is writing observational proposals. So, what is common in astronomy is that all the telescopes are owned by different space agencies, which are government agencies. So, you don't really pay for observations because it's public money that has paid for developing these telescopes. So the way it is done is that observers around the world, astronomers will submit a proposal for what they want to do with the telescope. So they will say, okay, I want to observe this target for this much time, and these are my specifications for observation, and these are the scientific basis that I'm basing my proposal on. And if the scientific rationale is really good, then they get the observation time. So for each time you want to make a new observation and you have a new project for which you need new data, you have to write a proposal to the telescope. And these days we don't rely on only one type of telescope. So we apply for three, four different telescopes with different electromagnetic bands. So we apply for X-ray observations and infrared and optical and radio observations and together. So in a year you're writing multiple different proposals all the time, and then you have to, and these days, we are also moving on towards a system where essentially, when you write one proposal, you have to review 10 other people's proposals. So that kind of adds up to how much amount of work that you have to do.
Yeah, yeah, absolutely. I mean, I can completely imagine. I can only imagine, of course, because I've never been a, I've never worked in the academia before. So listening to you makes me think that engineering is probably much way easier. All you need to do is debug some code, write some code, debug, and make sure it works.
I think the main difference I would say is that the project is yours. Essentially, there's no boss all the time telling you what should be done and what should not be done and giving you exact targets. And also, the other thing is that you don't have very specific set goals in terms of what you will achieve from a project. Of course, you have certain aims that you want to see from your proposal and from your observation, but it's not clear what the observation will show up. So it's always partially a question of how do you deal with the data, how do you work around it, and also what will the data throw up, and how do you answer those questions along with that. So it's very different from engineering where you have a set task where okay you need to develop this code for or you need to develop this instrument for this specific purpose and you have set benchmarks and so on. While with research it can be that okay we observe several different objects but then the observations were not good enough so we need to start again, or even with good enough observations we cannot find out the result what we want, or it's not sensitive enough or something like that, and either it's wait for 20 years for a better telescope or try something else. So it's an iterative process where you're trying to figure out how things work. And when you're thinking in that way, what happens is that you're trying to find out a needle in a haystack, but you don't know whether needle exists or not. So it's a very complicated process where essentially you're like a blind person in a dark room trying to figure out where everything is.
Yeah, and you could still be wrong at the end of the day.
Yes, no, you are 100 almost certainly wrong. In 10 years, somebody will prove you wrong. It's just an iterative process that every 5, 10 years you are updating the theories and sort of seeing what has remained right and what has changed.
Yeah, so it's always quite open-ended, very exploratory kind of a.
Exactly. Yeah.
How do you see astronomy research, changing in the next few years, or let's say in the next decade, given these many, many satellite mega constellations planned? Because already Starlink, there's the astronomer community has already been quite pissed off at how Starlink was polluting the night sky. So how do you think it's going to pan out?
Yeah, I think that is going to be a major problem because although Starlink is one constellation, there are different constellations planned from many companies, and the total number is just rising up and up. And even right now, many observations have the streaks of satellites going through their observations, sometimes going through the target itself, so you can't really do anything anymore, and you just have to throw out those observations. And these observations are expensive. So for example, some of the optical telescopes on ground, they cost tens of thousands of dollars per hour to observe. So although we don't pay it in terms of asking for observations, but the government is paying for operating those telescopes, and the demand is very high. So if your observations are getting destroyed because satellites are going through your data, then that becomes a problem. But optical data is not the only problem. Uh, the issue also is in radio because the satellite frequencies where they communicate with Earth, those are also very near to some of the astronomy restricted frequencies that they observe in. So you often get spillover or likely to get, especially for the next generation telescope. There is the square kilometer array which is planned in South Africa and Australia. So some of the bands for those telescopes will be quite similar to what Starlink is going to observe in, and then that is going to cause problems that it's not simple as removing some kind of a streak going through the image that will be easy. Maybe sometimes it's easy in optical telescopes, but with radio, the kind of issues you get are just impossible to correct. You get all these kinds of spikes in the data and uh, noises and so on. Like the radio telescopes are so sensitive that, for example, if somebody starts a car near a radio telescope, that itself comes up as a spike in your observations. So even something like a small spark plug of your car or a bike that is seen up. Most of the times you're not allowed to have mobile phones and microwaves around. So when you have satellites which are just blasting full speed with high intensity to the ground, then radio observations might be completely destroyed at that point. And the solution that sometimes, especially Elon Musk, always thinks like, oh, ground-based astronomy is no more, and we need to send all the telescopes to space anyway. But we have seen these streaks also in Hubble data, and Hubble is a space telescope. And even there, you get the satellites coming in front of the images and destroying the image. So even if sending things in space, that is not going to solve the problem. And of course, sending anything to space is very expensive, and he knows that.
Yeah.
But uh, the advantage of ground-based astronomy is that compared to space projects, for example, James Webb Space Telescope, it's a fantastic work, but it's been delayed by so many years. And once it's sent there, there is no way to repair it or upgrade it or anything. It's gone, and that's it. There is no kind of a upgrade that's going to happen to keep it running for another 20 years, 30 years. While ground-based telescopes, you can keep on upgrading the telescope instrumentation and all the kind of back end that is available in the telescope and keep on running those telescopes for longer and longer. So many of the telescopes that we use are 20, 30, 50 years old and they're running perfectly fine. You just upgrade them with the new electronics and new systems and they work fantastically. And a lot of the bread and butter science is being done by ground-based observatories. Of course, there is a lot of extensive work also, which gives fantastic results, which are groundbreaking results, especially once you have a new observatory which is bigger than the previous generation. Even the ground-based observatories will give you fantastic results. So you don't have to wait for the Hubble telescope and the next generation of that and so on to get new results. A lot of the results are being made by new generations of ground-based observatories. And also in science, as I mentioned, you need to have a statistical sample to understand what is really going on. You cannot just base everything on new results of a one object. So you have to have large samples and large number of observations, collect a lot of data, and for that, the latest telescopes are too expensive. So sometimes you have to have a combination of one or two observations with the latest telescope and then a large number of follow-up observations with ground-based telescopes where you can get a lot more data and have more control over the statistics. And so in that way, you really cannot get rid of the ground-based astronomy. So these satellite constellations are going to become a problem, and I hope there is some regulation of those in terms of restricting the frequency range, restricting how much luminous they are in the sky so that they are not too bright. Currently, there are just no restrictions how you can develop them and how you can launch them. And unless there is a global decision on this, it can end up being a space debris problem, essentially, that you have so many hundreds of thousands of satellites planned in orbit that eventually you are going to end up with a massive problem in space.
Yeah. I mean, I'm very surprised to learn that even Hubble images have streaks across them.
Yeah, it's not common, but if Hubble is observing something that is closer to the Earth's atmosphere, because Hubble is not very far away. Hubble orbits around like 300 kilometers above the surface of Earth. So unlike James Webb Telescope, which is orbiting at the Lagrange point 1.5 million kilometers away, Hubble is Earth orbiting. So when it's orbiting Earth and it's doing observations, sometimes you can get some small number of satellites still in the images.
Yeah, absolutely. I mean, this means the only way to get very assured good images is to put the observatory at a Lagrange point. But again, it's expensive, like you said, and space science budgets are, often at the bottom of the priority list for anyone.
Exactly. No, and also just sending anything to space is such a risk, right? It's a gamble in terms of like a rocket explodes and your $10 billion telescope is gone.
Absolutely.
While on ground, you can develop the telescope. You can start with a smaller version and then build up bigger and better, and you can also keep uh, everything intact so that you're not worried about like something catastrophic happening.
You mentioned these regulations that would restrict the frequency ranges of these mega constellations. Do you think these regulations would first pop up in Europe? Because usually Europe, is more into sustainability and like the GDPR, a lot of other areas, Europe is quite ahead. So do you think these regulations will come up in Europe first, or the US will take the lead, or how do you imagine this panning out?
I think it might happen in the US first because, at least with respect to Starlink, they are talking with astronomers and the American Astronomical Society and the new generations of telescopes that are coming up. So the people there are also talking with Starlink and trying to figure out a solution for both of these aspects. So it might be possible that in the next few years we will get some kind of a resolution on that. But also, often you need the US to agree to something, or especially US and China to agree on these regulations, because these are some of the big countries where you will have the large number of satellites coming in, and sort of you don't want to have the big country with the biggest stick in the world to just say, oh no, we don't care about your regulations, we are going to do whatever we want, which is what's currently going on in terms of like there is no regulation on how many satellites can Starlink or similar kind of company. So there is OneWeb and a few other companies which have planned this. So there is no limit on how many they can send. The basic check that they had to do is with the federal agency in the US, that any kind of satellite launch that has to do, but they don't have to do any verification or regulation about how are they affecting ground-based observations for astronomers or something similar. They don't have to worry about that because there are no regulations. So currently, they can just send as many satellites, and there are few very strictly restricted frequencies that they cannot use. But apart from that, there are many frequency bands which are available for use for them. And if they are getting too close to the observation frequencies that astronomers use, then that will become a problem.
Majority of the space activity, of course, happens in the US. So, yeah, that would be interesting how it's going to be. Speaking of opportunities in astronomy and astrophysics, I'm sure something has changed. So, what has changed in, let's say, India and Europe in terms of opportunities for someone interested in pursuing this path?
I think there are few things which have remained the same and few things have changed. So the advantage right now is that we are in the era of large amount of data. So the big data, as the buzzword goes, that there are many telescopes which are currently on running, which have large amount of data which are publicly available. So you don't have to be situated in a specific country or have access to specific telescope to be able to do a lot of groundbreaking work. So you could be sitting in any country and access the data. The archival data become public within 1 year of observation. So after 1 year, everything is public. So there is petabytes and petabytes of data from all kinds of observatories that are available. So that has made it easier for people to plan out their projects and work with very great quality data sets. In the past, what used to happen is that if you were from a global south country and you wanted to use best quality data, then you would have to have collaborations with Europeans or Americans or something like that. And then with through collaborations, you can obtain some data. But of course, with the advent of better quality data sets and ease of doing analysis, with everything moving to Python and similar languages, where now the limitations for starting up learning how to do data analysis is also much lower. So you can get a lot of data and work with that and develop projects for especially bachelor's and master students for them to learn their sort of first steps towards data analysis and understanding how things work. So this has become a really good step forward for astronomy. But otherwise, some things have remained the same in terms of that academia has not changed too much. So the number of positions that are available for permanent positions. So if you want to become a professor or something equivalent, so a permanent research scientist, then the number of positions are very small, and those haven't improved significantly in the last 20 years. So what has increased is the number of people finishing their PhDs. So that has become quite large, and more people are interested in doing PhD and coming into astronomy and so on. But almost 90% of the people will not have a permanent job in astronomy or academia. So essentially, the number of professorships or permanent positions have not changed in most of the countries. And most of the science budgets of these countries have also remained the same. Part of the reason is that the two financial crises we have had in the last 20 years. Because of that, every country, when there is a financial crisis, the first axe falls on the science budgets because that's the least important in that sense. Sometimes you will have ministers saying, like, well, as there is a ongoing war in Ukraine, that if you are not building military equipment, why do you need money? So these kinds of political issues also can affect science budgets, and there has been also quite a few changes. For example, in Europe, after the 2008 market crash, in southern Europe there was a big brain drain that Italy, Spain, Greece, these countries lost a lot of funding because their governments lost a lot of money during the crisis. And because of that, there were a lot more people moving out of those countries, moving into Northern Europe or to US and other countries. And things have not gone back to before 2008 yet. So in that way, there is a lot of competition. You have more and more people coming from also global south countries. So for example, from India, China, Southeast Asia, from South America and Africa also, there are more people who want to become astronomers. And of course, that is a fantastic thing. But the governments from these countries have not increased their science budgets and also funding that much. So you don't always have the equivalent number of permanent positions or even some good balance between how many PhDs you get and how many permanent positions you have. So that is still the limitations of if you're looking for a very long-term career in astronomy, then for 90% of the people, that is not going to be the case.
Wow, 95% is a big number. So, what are these people going to do if they are not going to land permanent jobs?
The flip side of this is that there is almost no unemployment with people with astronomy PhDs. So almost all of them find a very fantastic job outside of academia, and most of them are earning about twice or thrice that what astronomers earn. So many people, because we work with a lot of data analysis and we have excellent mathematical and physics backgrounds. So our skills are very useful in data science, data analytics, IT fields. So these are primary ways where people are going. So physics, mathematics, astronomy PhDs are very much in demand in these fields. So if you have a PhD in these topics, then a data science job is not too difficult to get. And most people, after their PhD or one or two postdocs, they transition to industry job like that. There are a few people who go into sort of semi-industrial, semi-academic jobs. So people working with space agencies. So many of my colleagues who have gone from PhD to working with DLR or European Space Agency, but not in astronomy, but they are working with space launch or satellite manufacturing and so on. So people also transition that way. Some people go into more of the administrative side, so going into patent offices or something like that, or you can also go into teaching if you are interested in that. So there are a few people who also don't find research too interesting after finishing their PhD. So I have known a few people who also went into either high school or undergraduate level teaching. So you have a quite mix of opportunities available.
Okay, that's very nice to know. Are you planning this kind of a pivot in your career next?
I don't have any immediate plans. I have a permanent positions in this institute now, so essentially, at least in the short term, I'm not thinking of making any change. And I'm currently under so many projects that essentially I don't have time to think about anything else right now. So I'm just working with my astronomy career for the foreseeable future. But you never know what how things change if there is another global market crash and they decide to halve the scientist population. I might be out of job in 5 years or 10 years. Who knows?
Well, you'll always have a more lucrative job, at least in terms of pay, waiting for you.
Yeah, but after a certain point, then you become unemployable in a sense that your experience in astronomy does not always count because they you have to sort of build your resume and experience in that way, and you have to keep up with the industry also. So it might not be easy to immediately transfer if you're like a middle career or a slightly later career academic. Then sometimes you might be too senior for certain jobs while you might not have the same kind of project management or management experience that is required for the senior positions in uh, private sector. So it can be difficult to transition once you're in the middle career or further. But it can also be like it depends on what your personal background is, how much your work experience has been, how you have developed yourself during that time, and if you have done quite a lot of management interactions with people and so on, you can build your resume and your profile so that it's easy for you to transition. And sometimes it's also a matter of how you present your work and how you present yourself, because in academia we learn quite a lot of things. We are jack of all trades, and we learn quite a lot of things where it's quite hodgepodge of different topics. So we do pure research, so we are doing data analysis and programming and scripting and all of that stuff, but we are also doing public speaking. We give presentations both to other experts but also to general public. We are writing, so we have expertise in scientific writing as well as public writing, so we write for newspapers and articles and so on. Often many of the scientists will also go on television and podcast and have that experience. So you have these expertise, you have excellent expertise in giving presentations of technical topics and making them understandable to various different levels of audience. So these are all very beneficial for a private company because these things you have to build up in your employees, and that requires training and so on, while many of the academics come with that training already. So it's a matter of how you present it in your CV or in your interview.
What kind of backgrounds and geographies do your colleagues come from? The ones you currently work with in the Academy of Sciences?
Yeah, so most of my colleagues are actually very local. So here in our institute, a large number of people are local Czechs or Slovaks, but we also had in the last 5 years we had quite a lot of influx of people, but it's usually on a short-term contract basis. So essentially, we have 2 year or 3 year projects, and we hire people for that as a postdoc. So we have had people from US, UK. I have colleagues from various parts of Europe, so Greeks, Hungarians, Polish, and French, and so on and so forth. And we also had a few Indians working in our institute, and so we have a very mixture of people.
Okay, so I believe it wasn't that hard to land opportunities, let's say in Germany and as well as in the Czech Republic or Czechia as a non-EU national.
No, it's usually not too difficult as long as you have a good academic background and good recommendations from your advisors. Then getting a PhD positions or a postdoc can be possible. And within that, so I did my PhD with the Max Planck Institute in Bonn, and there the cohort of 60, 70 people. Usually, you have a wide variety of people from all different continents. We had Australians, many Indians, people from Middle East, a few people from Africa, several people from Europe and North America and South America. So we had a very good mixture of people from all over the world. So it was not like very narrow case where 90% of people are Europeans and only 10% outside. It was mostly about 40% of the people were Germans because, of course, it's a German institute. But then the 60% people were from outside of that.
Circling back to what you said about data analysis and writing a lot of code, what kind of tools or softwares do you use on an everyday basis? And how and when did you pick up all these programming languages?
Yeah, so most of it was kind of self-taught. So during my PhD and before that, during my master's, I was using Fortran, which is like the classical scientific programming language. And around 2013, 2014, I decided to make a change from Fortran to Python, partly because Python was easier to code in, and it's a much easy writing language for writing scripts and doing short snippets of code. So if you're writing a program that is going to be used by a large number of people, or if you're writing a program that is going to do intensive calculation, then you should be doing it in Fortran or C++ or something like that. That is much faster and it uses resources more efficiently. But for the kind of data analysis I do, it's mostly statistical analysis on the reduced data. For that, it's more the ease of writing the code, and also analysis is much nicer in Python. So I made that shift around 2013, 2014. And it was mostly looking at online tutorials and so on. And once you have a decent background in one programming language, making a shift is not too difficult. And what I do mostly is scientific statistical analysis, and coding is sort of related to that. So we get large amount of data, which is often in some telescope format, and then we have to reduce it into getting the images and data sets, and then we do the data analysis, asking specific scientific questions, and then doing the calculations on those, and then finding out the results from that. So that is the kind of analysis we do. Uh, but there are other people who work on purely simulations, and they are working on much more extensive, where they work with large n-body simulations or hydrodynamic dynamical simulations, where they are using much more sophisticated codes. The code itself might be written in Python, but then the Python that feeds into some more sophisticated language like C++ or Fortran or something else. And then there are people who actually develop these programs also. So there are people who are doing the developing of different softwares and toolkits, as well as different algorithms. So these people might be working with completely different toolkits than people who do just purely data analysis. So depending on what kind of work you do, you have a very large variety of languages you can work with.
Coming to my super favorite topic of space sci-fi, I mean, I still remember you're the one who introduced me to The Expanse.
Oh yeah,
long, long ago. And also, I mean, I don't know if you remember, but your Twitter handle is Marvin, right?
Right.
That's also, I guess, how we met on Twitter. We share the love for the Hitchhiker's Guide to the Galaxy and all the references to it, the paranoid android and the Marvin and all these. So, what's your favorite space sci-fi so far?
Ooh, that is a very complicated question because I have many different favorites on different genres. But I think the recent one that I really enjoyed was a series by Adrian Tchaikovsky.
Hmm.
It's The first book is called Children of Time. Second book is Children of Ruin, and the third is Children of Memory, which I haven't read yet. I have read the first two books, and that one has been one of the best sci-fi stories I have read in last 10 years. I think it's kind of a modern classic. So it's a story. I don't want to give too many spoilers, but it's a story that takes place few thousand years in the future, where humanity has developed terraforming technologies and so on.
Wow.
And there is one person who is trying to play God, essentially, that she wanted to have a world of her own where she would take chimpanzees and apes and then feed them a nanovirus that they have developed that will elevate them so they will sort of be uplifted to human intelligence or even superhuman intelligence. And she wanted to create a civilization using those apes, and she would be their god. But then things go bad, and the apes never reach that planet, and the planet was terraformed with earth, insects and plants and everything. And the virus that she had developed that affects all the insects and other smaller animals. And it's a story of how the spiders get affected by that virus and how they develop in the future.
Are you giving away the plot or?
No, this is just the first chapter.
Oh wow. Okay. This is already at the top of my to read list now.
The first book was a complete revelation. I have not seen somebody describe evolution in such a very amazing way, where you look at the characters that he is developing and how they interact with each other. And there is a very interesting dynamics between different characters. So I will not talk about what characters they are, but the interaction is very excellent, and the development of this technology, it's amazing stuff.
This is incredible and it's pretty new. I just looked it up. It's published in 2015, not too long.
Yeah, it's been one of the best sci-fi books coming in the last 10 years.
Since you mentioned evolution, there's another book called The Dragon's Egg. I don't know if you read about this.
I have not read it, but it's on my to-read list.
Yeah, it talks about how intelligence evolves on a neutron star.
Right, yeah,
That was also quite incredible, but I'm sure this one will be many times that since it's a book series.
yeah.
Very interesting. I cannot wait to, process this podcast and then go and jump into reading The Children of Time now. This is incredible. I don't know how I missed that.
Yeah, the other book I would suggest is the another series is by Sichin Liu. If I hope I'm pronouncing it right.
Oh, yeah, the three body problem.
Three Body Problem. Yeah, that one was also fantastic.
Oh, that was incredible. I was desperately looking for more books like The Three Body Problem because it approaches space sci fi from a multitude of perspectives, right? Cultural level, technological, political.
Exactly. Yeah, it's these are kind of books which are in the same vein as the classical sci-fi from the 50s and 60s,
Hmm.
but written in a much better way.
Yeah.
In a sense, like the characterization is much more complex and nuanced, and you also have more dynamics going on, but you still have the sort of sci-fi concepts that you come for. Like you get characterization in every fantasy and literary genre, but you come to sci-fi for the ideas, and these books are filled with many different ideas, which are just fantastic to read.
Yeah, absolutely. I just love drowning myself in these. And I'm also a little bit surprised. I thought you would, because when I talk to some astrophysicists or, astronomers, their every day to me seems like living, like I said, like living inside a sci fi book. But if you were highly recommending this, then I'm sure this is something else.
I mean, for me, sci-fi has been one of my first loves in reading. That I got into astronomy because of sci-fi. It's actually most people in astronomy come because they like doing stargazing as a kid, and they like looking at the stars, and then they want to develop that as a career. But for me, it was not that. I was not much enthusiastic about stargazing, and even now, I can. The only objects in the sky I can tell are the sun and the moon. Everything else is just points.
Wow, this is so cool to know because I thought, I mean, usually people, a lot of my friends and a lot of my family, they're not into the space sector, and because I work in space, I'm just an engineer, I'm not even a scientist. They think I know everything there is to be known about the sky, and then they point to random things and say, "Hey, what's that?" I'm like, I have no clue. It's like, where is your telescope? I'm like, I don't have one.
Yeah, it's the same with me that people will ask me, okay, what is that object, or do you have your telescope in the backyard, or do you use telescope from your institute? And I'm like, no, my telescope is located in Chile.
Oh, that's so badass and so cool.
Yeah, but yeah, for me, my interest in astronomy started actually when I was 13, 14, and I started reading science fiction at that time.
Mhm.
And that really got me interested in doing science and learning about physics and astronomy. And scientists were always in one of these sci-fi stories, and they were some of the coolest people. So I always wanted to be like that. So that really got me into astronomy. That learning about these various different weird sci-fi concepts, which also had some basis in science, and getting to know what the science behind those is, even when they are more of the esoteric concepts like wormholes and hyperspace travel and so on. But just there were so many concepts which are based on reality that got me interested in learning more physics and astronomy, and then that got me into, okay, I want to do astronomy as a career.
Wow, I completely relate with that. One of the biggest reason for me to get into space was also space sci-fi or sci-fi, and it's still the biggest reason keeping me in space.
Oh yeah, that is 100% true. Yes, living on Earth is fantastic, but how cool it would be to roam around in the stars.
Absolutely. Speaking of roaming around in the stars, I don't know if you've read the Wayfarer series by Becky Chambers.
Yes, I have it just in front of me. I am reading
Oh,
this just right now. Currently, I'm on page 70 of that.
how do you find it so far? It's not as deep.
Yeah, it's very light-hearted reading so far, and it's not very deep. So the previous couple of books that I mentioned, those were much deeper in the sense that you had to really think and understand what's going on and pay attention. So it's not something that you will just sit one day with a cup of coffee and finish the book in one afternoon. Well, this feels like a much more fast-paced, but you can read it quickly and is not too intense, but it's much more fun.
Yeah, absolutely. I don't think I've laughed more. I've ever laughed as much as I've laughed reading this book. I would read it on my commute to work and then just burst out laughing, freaking everybody out.
Yeah, I can imagine. Yeah, so far it's been really fun. I'm looking forward to reading this and then continuing the series.
Oh, the books just keep getting better. I always thought, okay, this book is gonna be the epitome of fun, but then it just keeps getting better. So
Oh, that's fantastic to know.
yeah, you're in for a treat. It's always so much fun talking about everything space with you, Abhijit. And you've shared a lot of very interesting insights, into building a career in astronomy and astrophysics. You've shared a lot of insights. And if space enthusiasts or young professionals want to reach you, what's the best way to do so?
I think the best way to reach me would be email. So they can contact me on my personal email, contact at abhijeetborkar.com, and that should be the fastest way to get to me.
It was super fun as always chatting with you, and thanks a lot for your time.
Yeah, thank you for having me. I also had really fun talking with you, and especially connecting again with the love of science fiction. That's always fun to talk about. I could go on for hours and hours talking about my favorite sci-fi.
Oh yeah, yeah, absolutely. But let's do that in person next time. I'm in Prague, or you're in Berlin.
Definitely.